In this class, we are going to talk about diatomic elements. We're going to look at what is meant by diatomic elements, examples of diatomic elements. We're going to look at their properties and their chemical bonding. Okay. Now, the big question is, what is meant by diatomic elements? Diatomic elements are elements that naturally exist as molecules made up of two atoms of the same element, chemically bonded together. So if you look at this word, di simply means two, you understand? And atomic simply means atom, you understand? So when we're talking about diatomic elements, they are elements in which at their natural state they consist of two atoms, you understand? And when we have two atoms, we are talking about molecules, you understand? Do you understand? So that simply means that diatomic elements are elements that naturally exist. At their natural state, they exist as molecules. These molecules is made up of two atoms of the same element. You understand? So that is why we call them diatomic elements. And they are chemically bonded together. There are 7 diatomic elements that you need to know. You understand? There are 7 diatomic elements that you need to know. We have, the first one is hydrogen. Okay? The first is hydrogen, that is H. Now, hydrogen at room temperature, that is at their natural state, it exists as H2, you understand? Hydrogen in its natural state exists as H2. Another type of diatomic element that we're going to talk about is the nitrogen, you understand? We have the nitrogen. Okay, we have the oxygen, that is O2. We have the fluorine. Okay, then the fifth, we have the chlorine. We have chlorine here, that is Cl2. We have bromine, that is Br2. Then we have, which is the 7th, that is iodine, that is I2. Okay, these are the 7 diatomic elements that we have on our periodic table. You understand? Now, see, you can use this mnemonic device to remember all these diatomic elements. You understand? Just use this H NOV CBI. If you can remember these acronyms, you are going to remember all these diatomic elements. H stands for hydrogen, N stands for nitrogen, O stands for oxygen, F stands for fluorine, C stands for chlorine, B stands for bromine, and I stand for iodine. You understand? So if you can remember these, these acronyms, this is just a mnemonic device that you can use. You understand? To remember all these diatomic elements. Now, these elements are diatomic because it is at this state that they are more stable. You understand? For example, let's take for instance hydrogen. Hydrogen is not stable as H, you understand? So it's only stable as H2, you understand? And you can see the reason why we call them diatomic is because they have the same atom of the same element, you understand? Okay? Now, having understand the reason why we call them diatomic, let's look at their bonding, you understand? Let's talk about their Lewis structure. Okay? You know, hydrogen has only one valence electron, you understand? So H2 will form. This is the bond between H2, you understand? They are going to share, it's going to share the bond, you understand? It's going to share the electron. The bond between all these diatomic elements is known as covalent bond, as it involves sharing of electron, you understand? Electrons are being shared. Now, let's talk about nitrogen.
Hydrogen
is the 7th element on the periodic table.
And if you look at nitrogen very well, you will discover that it has only 5 valence electrons. So, in order to satisfy the octet mode, you understand, the numbers of valence electrons required to complete the octet rule is 3. You understand? So in an attempt to do that, the bond that is going to exist between the two atoms of nitrogen will be 3. Do you understand?
To complete this valence electron are electron that is at the outermost shells. You understand? So to complete this valence electron, nitrogen requires 3 electrons. You understand? So the bond between the two atoms of nitrogen that we have will be 3 bonds. You understand? So that means we are going to have something like this. The nitrogen here, then is going to have 3 bonds. Electron is being shared. So because to satisfy the octet rule, it requires 3 electrons. Are you paying attention? So that is why we have this. Now let's proceed to the third diatomic element. We have the oxygen. Oxygen is the 8th element on the periodic table. You understand? And if you want, let's say we have oxygen, we have 1, 2, 3. You understand? Because it has 6 valence electrons. You understand? So that means that to complete the valence electron, it requires 2. You understand? In order to satisfy the octet rule. So here we are going to have oxygen. How many bonds will oxygen form like that? It's going to form 2 bonds. You understand? Because oxygen is 8 on the periodic table. So it's the 8th element on the periodic table, and it has 6 valence electrons. Now, to make the valence electron 8, you understand? An element that will satisfy the octet rule, its valence electron must be 8. You understand? So to satisfy the octet rule, it requires 2 electrons. You understand? So that means that it's going to have 2 bonds. Okay, so oxygen is going to have 2 bonds. Do you understand? Okay, so you can just put the electron here. You can put the electron here as well. Now we have the 4th diatomic element, which is fluorine. Now fluorine is has 7 valence electron. You understand? So it only requires only 1 electron to complete its outermost shells. You understand? So that means that it's going to form only a single bond. Hello? It's simple. You understand? The numbers of bond is determined by the numbers of electrons that this atom require to make them to satisfy the octet rule. You understand? What I'm trying to say is that the numbers of bonds that exist between these diatomic elements depends on the numbers of electrons required for them to complete their valence electron. Okay, so here fluorine is going to form only 1 bond. Okay, fluorine is going to form only 1 bond because it has 7 electrons already. You understand? So now the next diatomic element is chlorine. You see, all the elements that you find on the groups that have 7 as their valence electron, they are group 7 elements, and they are also known as halogen. All the halogen among the diatomic elements include fluorine, chlorine, bromine, and iodine. So they also form 1 bond, such as fluorine. You understand? So all these halogens, such as fluorine, chlorine, bromine, and iodine, they have 3 lone pairs. Okay, so even though all these elements they have common properties, such as all of them are non-metals, you know, they form covalent bond. I've already explained that, and they are co-conductor of electricity. You understand? That is, they are non-metals. So now, even though they have all these properties, they also diverse. You understand? They have common properties, but their state of matter at room temperature varies based on their physical properties. For example, there are some of them that exist as gases at room temperature, and there are some that exist as liquid and others as solid. Okay, now if you want to know those that exist as gases at room temperature, we have the hydrogen, we have nitrogen, we have oxygen, and fluorine and chlorine. You understand? We have hydrogen gases. Okay, we have hydrogen, we have oxygen, we have fluorine, we have chlorine. You understand? These four elements, okay, chlorine. Nitrogen is also part. You understand? So you see, all these elements, they exist as gases at room temperature. Okay. So now, bromine and iodine. Bromine is liquid at room temperature. You understand? While iodine is solid at room temperature. You can see now. So bromine, we have Br, and solid we have iodine. Do you understand? So you can see, even though they have common properties, they are both, all of them are non-metals, because they are co-conductor of electricity. You know, the bond that exists between their atoms is covalent bond, as it involves sharing of electron. But they differ based on their physical properties at room temperature. Some of them exist as gas. Example is hydrogen, oxygen, fluorine, chlorine, and nitrogen. While liquid, we have bromine, and solid, we have iodine. So that will be all for this class. If you have any question regarding this, let me know in the comment section. Okay, see you in the next class.